Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: AWS Lambda and Serverless Architecture. AWS Lambda, a key component of AWS's serverless computing services, offers a paradigm shift in how we think about computing resources. Serverless architecture represents a significant departure from traditional server-based computing, where server management and infrastructure provision are abstracted away, allowing developers to focus solely on code. AWS Lambda enables developers to execute code without provisioning or managing servers, scaling automatically with the size of the workload and integrating seamlessly with other AWS services. AWS Lambda allows developers to run code in response to events such as changes in data, shifts in system state, or user actions. This event-driven model supports various applications from real-time data processing to backend services. With Lambda, developers can write applications in several languages, including Node.js, Python, Java, Go, and C#. The flexibility of language choice and the convenience of automatic scaling make Lambda an attractive option for modern application development. One of the primary advantages of AWS Lambda is cost efficiency. Traditional server-based architectures often involve paying for idle resources, as servers must be provisioned to handle peak loads, which can lead to underutilization. In contrast, Lambda follows a pay-per-use model, where charges are incurred only for the compute time used. This model significantly reduces costs, especially for applications with variable or unpredictable workloads. Research indicates that serverless architectures can reduce infrastructure costs by up to 90% compared to traditional architectures. The automatic scaling feature of AWS Lambda ensures that applications can handle varying loads without manual intervention. When a Lambda function is invoked, AWS automatically provisions the necessary resources to execute the function, regardless of the number of requests. This scalability is particularly beneficial for applications with high variability in request rates, such as web applications or IoT data processing. For instance, a web application experiencing a sudden surge in traffic due to a viral event can seamlessly handle the increased load without performance degradation or manual scaling efforts. Another critical aspect of AWS Lambda is its integration with other AWS services. Lambda functions can be triggered by events from services like Amazon S3, DynamoDB, Kinesis, SNS, and many others. This tight integration enables developers to build complex workflows and data processing pipelines with minimal effort. For example, a Lambda function can be triggered by an S3 event when a new file is uploaded, process the file, and store the results in a DynamoDB table. The ease of integration with various services allows developers to create highly performant and scalable applications with less code and configuration. Security is a paramount concern in any computing architecture, and AWS Lambda provides robust security features. Lambda functions run within a secure and isolated environment, ensuring that code execution is sandboxed and does not interfere with other functions. Additionally, AWS identity and access management policies can be used to control access to Lambda functions, specifying which users or services can invoke specific functions. This granular access control ensures that only authorized entities can trigger Lambda functions, enhancing the overall security posture. Developers can also take advantage of Lambda's built-in logging and monitoring capabilities through Amazon CloudWatch. CloudWatch collects and tracks metrics, collects and monitors log files, and sets alarms, providing comprehensive visibility into the behavior and performance of Lambda functions. This visibility is crucial for debugging, performance tuning, and ensuring that applications meet their SLAs. For example, developers can use CloudWatch logs to identify performance bottlenecks or unusual behavior in their Lambda functions, enabling proactive troubleshooting and optimization. Despite its many advantages, AWS Lambda and serverless architecture come with certain challenges. One of the primary concerns is the cold start latency, which occurs when a Lambda function is invoked after being idle for some time. During a cold start, additional time is required to initialize the execution environment, which can lead to increased latency for the first invocation. This issue is particularly relevant for latency-sensitive applications, where even slight delays can impact user experience. However, AWS has made significant improvements in reducing cold start times, and various strategies, such as provisioned concurrency, can mitigate this issue. Another challenge is the stateless nature of Lambda functions, which necessitates external storage solutions for maintaining state across function invocations. While this design promotes scalability and fault tolerance, it requires careful consideration of data storage and retrieval mechanisms. Developers often use services like DynamoDB, S3, or Redis to manage state, which can introduce additional complexity and latency. However, the benefits of a stateless architecture, such as improved scalability and fault isolation, often outweigh these challenges. The event-driven nature of AWS Lambda aligns well with microservices architecture, where applications are composed of small, loosely coupled services that communicate through APIs or events. Lambda functions can serve as individual microservices, each responsible for a specific piece of functionality. This modular approach allows for more straightforward development, testing, and deployment, as each function can be developed and deployed independently. Furthermore, the isolation provided by Lambda ensures that issues in one function do not impact the overall system, enhancing reliability and fault tolerance. Real-world use cases of AWS Lambda demonstrate its versatility and effectiveness. For example, Coca-Cola used AWS Lambda to build a serverless platform for its vending machines, enabling real-time data collection and analysis. This solution improved operational efficiency and provided valuable insights into machine performance and customer behavior. Similarly, FINRA, a financial regulatory organization, leveraged Lambda for real-time data processing and analytics, handling billions of market events daily with high scalability and cost efficiency. In conclusion, AWS Lambda and serverless architecture offer a powerful and flexible approach to building modern applications. By abstracting away server management, enabling automatic scaling, and integrating seamlessly with other AWS services, Lambda empowers developers to focus on code and innovation. The cost efficiency, scalability, and security features of Lambda make it an attractive option for a wide range of applications, from web services to real-time data processing. Despite challenges such as cold start latency and state management, the benefits of serverless architecture, including improved scalability, reliability, and modularity, make it a compelling choice for many organizations. As adoption of serverless computing continues to grow, AWS Lambda is poised to play a critical role in the future of cloud-native application development. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.